when VisiCalc first came out, you could explain it or show it to people, okay? And if you showed it to a computer person, they look at it and say, what's so special here? I can write a program that does that, and I can do better, and stuff like that. You show it to a regular person, a normal person, they say, computers can do anything. They can forecast the weather. What's so special about that? But if you showed it to people who actually did that stuff, they would start shaking and say, here's my credit card. Please take it. Give me that. Give me that.
How did the best machine learning practitioners get involved in the field? What challenges have they faced? What has helped them flourish? Let's ask them. Welcome to Learning from Machine Learning. I'm your host, Seth Levine.
Hello and welcome to Learning from Machine Learning. On this episode, we have a very special guest, Dan Bricklin, the co-creator of VisiCalc, the first electronic spreadsheet, and really the first killer app that helped launch the PC revolution. Dan has lived through every major computing platform shift from mainframes to today's AI. Few people have a better perspective on what separates transformative technology from hype. Dan, welcome to the show.
I'm glad to be here. Thanks a lot, Seth.
It's such a pleasure to have you. Let's get right into it. So what initially attracted you to computer science, computers in general?
Well, as a child, this is back in the 50s and 60s. I was, I love technology and, mechanical stuff and electronic stuff and whatever. And I would read Popular Electronics magazine. That was one of my favorites. So a computer seemed like, I didn't know what it was, really, how they worked or how to make them. But I knew that was pretty cool stuff. And I knew some of the electronics of how to do whatever. But so I was interested in that. The first time I actually saw a computer I was quite young. I was early in grade school, and I visited my grandfather, editor of a small newspaper, and I visited him at work, and they had a punch card machine, the IBM punch card machine. They use it, I guess, for circulation, for subscriptions and stuff. And I was really taken by that, how it could do the sorting. And I actually built, for a science fair project, I built a rudimentary punch card sorter that you could crank it, and, as the thing went through it was able to tell, and the magnet would lift something and it would go here or there depending on it. So that sort of got me wanting to get into it. And so that attracted me. I was always viewed as a techie, into space and things like that.
Very cool. So then, we'll fast forward. You studied at MIT.
But I got into computers early. I got into computers when I was 15. My cousin came home from his school, and they had just gotten access to a time-sharing system. They were one of the few schools in the whole Philadelphia area who were able to do a version of Fortran called QuickTran using a remote type terminal. And I got to go over and learn. He brought the manual home, and I studied the manual and learned Fortran 2, and started programming. Like, one of the first programs that I wrote was, we had learned in school patterns of English. We learned about noun, verb, whatever, and that a sentence had this. So I put in all these types of sentences, and I put in a list of nouns and verbs, and it would make up sentences and stuff that were technically correct. I thought that was pretty cool.
That's very cool.
So that's one of the first things. And then I built a graphing program. I think a thing that did graphing, on the printer, the typewriter output. Then I would beg, steal, or borrow computer time to be able to improve my stuff wherever I could find access to computing. In those days, it was very hard for like a high school or anybody to get access to computers. But I learned how to be able to find where there were ones that I could get access to. They're usually, like the Bureau of Public Education in Philadelphia.
Right.
I was like the only one who would go convince them to let me go down and use their 1401 computers.
Yeah. It's so cool because it was like right as it was really becoming a thing. So not very many people had access to it. So
but these are all mainframes.
Right.
Right. In later high school, I took a summer course at the University of Pennsylvania, where the National Science Foundation had a programming computer course, and they had this 1130 computer that was brand new.
Right. And
I was able to program that and, learn computer stuff at that course. at the University of Pennsylvania, even though I was a high school student. And then I got a job at the person who ran that course, worked at the Wharton School at the University of Pennsylvania and worked in computational services. And I got an afternoon job in high school to be able to work there. And suddenly I had access to computers through the University of Pennsylvania.
Very cool.
As a high school kid.
Nice. Yeah. So I was at the engineering school at University of Pennsylvania. So every day when I would go through one of the halls, I'd pass the ENIAC machine. Is that, yeah. So
I guess, yeah, well, whatever. It was down the hall from where I took my course. I knew that there was nothing to look at or anything.
Yeah. Now it's just there behind glass and you can kind of look at it.
No,
but
so
yeah,
they built a shrine. So they
built
now
a
have a shrine. They
Yeah.
didn't have the shrine. I don't remember there being a shrine. I didn't see it. I just knew that it was somewhere. I was at the Moore School,
Yeah.
which is where it was done.
Yeah. Yeah. That's where I took
That's
a lot
kind
of
of
my
cool
classes.
to be, connected to the past. I like looking at the history of stuff. So it's nice to be connected to the past.
Yeah, definitely. Tell us a little bit like a mainframe computer. Like, so does it have all of the same things? How different?
Those days, well, in those days, I mean, they're very, very powerful for those days. Today, they're, my watch is more powerful.
Right.
Microwave oven is probably as powerful. They were in these big, the cabinets that look like big refrigerators, and multiple of them, and each one had different parts in that. Now we might have, half a chip or a fraction of a chip to be that whole thing. So there was the CPU, maybe a couple of them. There were tape drives, that were used for storage, for longer term storage, and there were disk drives, and stuff like that. And it produced a lot of heat, and they had lots of big cables for lots of power and stuff. So the floors were raised. They had, so you could pull a tile off and get underneath and, put the wires down there between them so you wouldn't trip, but also they could take air conditioning through it to get the heat off, and the air conditioners are running. You hear the noise when you go in there was a computer room, and you didn't go in there because you don't want to get any dust in there,
Right.
Or anything like that might mess up the card readers and stuff. So, you did things outside, and plus you don't want to give regular people access to that room. They might mess something up. But so that was what mainframes were like. They had CPUs, they had short-term storage and long-term storage and non-volatile storage, and they did all the same. They had computer languages, and you could connect terminals to them of various sorts to do visual stuff, or printed output with paper printers that could print, 10 pages a minute or something like that. And that's how checks were printed and reports and stuff. So it's a lot of what we have today, but just it was bigger. Just
Right.
like if you take today, literally within the last few days for any normal person getting it, you have Apple has a new phone where all the electronics are where the camera is. A little strip where the camera is the whole thing of the phone, because they've
Right.
miniaturized the whole phone down to the cameras and everything fit in a little strip, and the rest is battery and screen. But the basic idea of storage, computation, and display and input and those are all different parts. Software that runs on them. It's a stored program computer. That is, from an architectural viewpoint, it's very similar.
Right. It's pretty amazing to have seen the entire evolution and being one of the people that was accessing those mainframes to now see how that has all evolved into today. So some of the work that you did helped propel the PC, the personal computer revolution. You worked on a word processor pretty early on, right?
Yes. Yeah, very early on. I was at Digital Equipment Corporation after college. At the end of college, I worked on a system that used a language called APL that regular people, but mainly engineers and people like that, could type in a simple program and get the results out of it. But then when I went to Digital Equipment Corporation, which was a large mini computer manufacturer, I worked in computerized typesetting and worked with editing, for editing the articles that went through, for connecting to wire service stuff that's, data that's coming in from outside. And then I ended up in their first word processor. It was a computerized word processor, a document-oriented one. In those days, there were two types of electronic, with screen-based word processing. There were just a few companies that made any of those. And one of them was page-oriented, kind of like PageMaker or PowerPoint or something. You laid out one page and then you laid out the next page and you positioned things within that as you type. Document-oriented is more like Word, is what we're familiar with today. Ours used just one long thing of text and it broke it up into pages and cared about layout horizontally with tabs and decimal tabs that line up just right. And how do you do that? And I worked on that, which was to be used by typists and then hopefully by managers and executives, but they didn't type in those days, but they would give things off to typists. So I worked on that. That software ended up on all sorts of different hardware. It started out with a computer inside of a desk. The computer was big and the screen part of the desk. Eventually they sold it as a one-piece unit for about 10 years as the DECmate word processor. It started as a DEC WPS8 system. So, and it looked like this. Here is an ad for it. This is a typewriter. This was our system. That was on top of the desk, but you can see the desk with the floppy disks, the 8-inch floppy disks that went in it. So, and it could do output like this. This is the functional specification for it.
Wow.
For this thing written in itself, in an early version of itself. So I got to, that was word wrapping, being able to, and I wrote software that did some of that stuff. There was a team of about 4 of us doing the software for that word processor. Before that, I had worked on an editing system for newspapers. I was familiar with some newspaper systems that were specifically for editing, two-dimensional layouts, for giving the commands to a typesetting system, for doing the ads in a newspaper. I got to see those that people had. There was an interactive system called the Harris 2200 that you can't find too much about, but was a groundbreaking machine that was basically PageMaker and hardware. And that I was quite taken by. And that influenced VisiCalc in a way.
Yeah. So getting into VisiCalc. So, VisiCalc, I mean, widely regarded as fueling, the rapid growth of the personal computing industry. Steve Jobs went as far as to say that VisiCalc is what propelled Apple II to the success it achieved. He says that in an interview in like the 1990s.
Because it was only available for a year on the Apple II. Because software takes a long time.
Yeah. Where do you want to start with VisiCalc? It's referenced everywhere, right? Like in Prediction Machines, the book, it talks about that's like one of the first steps towards realizing the power of automation, change the way that people
because it was interactive computing. People were not used to interacting with a computer other than to put their card in and get money out of a machine, right? That was the main way that people interacted with a computer. Here was a thing, a word process, maybe they had tried a word processor, but here is a thing that, did things that they would have to do by hand. They were supposed to, but it could do it so much faster and opened up all sorts of worlds. So that really affected things quite a bit. It let people say, oh, this is what an interactive computer is. It's not just games. They did have access. They were playing Pong and stuff like that, Atari stuff.
Right.
So it can be useful in things that are better than anything else. Even a mainframe doesn't do anything. This interactive, me give and taking with it and getting the output that I needed, and it's custom to what I need. That just like a word processor. There were programs before word processors that would construct a will, would ask you questions and then write a will. But a word processor lets you write anything. That's a general purpose tool. Well, a spreadsheet was a general purpose tool for numbers, like a word processor was a general purpose tool for paragraphs or prose. For numbers and for also text. People often used it only for text to keep lists. And since you could lay things out any way you wanted, it was not strict columns and rows that all the rows are the same and all the columns have the same one. No, it wasn't like that. You could put anything anywhere, but you could take advantage of it. You could very quickly create things because it had just the right tools. to let you do things very fast because it was optimized for minimum keystrokes, because I came from typesetting where you're
Right.
paid by the keystroke. So I learned how to optimize for quick, and I was competing against paper with a calculator and a pencil and paper. And it had to be faster the first time you used it, because otherwise you wouldn't use the recalculation. If it was quicker, you say, oh, I only need this once, I'll do it by hand.
Right.
So that, I think that said people, wow, computers can be useful in so many ways. What other things can they do? This is interactivity. What you see is what you get. The thing is, you could build something and build on it and build on it and give it to somebody else. That, and then all sorts of other software start coming out.
Yeah. So you talk about it, you have like some sort of formula about figuring out if something can be like a killer app. You were kind of referencing it before, so you're comparing what was it before, right? Like people were trying to do spreadsheets existed, right? It just was the idea that you could use a spreadsheet on, on your machine, you could change one number and then that would lead to cascading of everything changing. You could put in custom formulas, you could do all of this stuff. I guess as you were making it, did you know the magnitude of what you were creating?
Well, of course it should be. Whenever you do something, you think it's going to be great. It usually isn't.
Yes.
I knew it would be very useful, but people were not adopting computers at the rate we expected. Word processing was not taking off at that point.
Right.
Back in 1979. It was not going like this. Normal people did not get it. I mean, it wasn't until the inexpensive computers like the Osborne and the K-Pro, that a journalist could buy their own computer to be able to take home and be able, with a word processor and all, and write things, and suddenly people could do their novels on a word processor. That wasn't until a few years later. And that was because PCs became popular. PCs became popular because I think one of them is people involved in money liked the spreadsheet.
Yeah.
They said, oh, these PCs are useful. And then when they were good for word processing, the journalist said, oh, PCs can be useful. And, and then people, their kids went away to college, and the only way to communicate with them was by instant messaging and email. Oh, computers can be useful when connected to a dial-in remote stuff. And then the internet, and so every time there is some new capability from a hardware viewpoint or hardware and software combination that is much, much, at least 100 times better than what was before. Like, think the mouse is so much better than arrow keys, right? In terms of precise positioning quickly.
Right.
Every time the laser printer compared to the typewriter output, it was a ball. Remember the Selectrics? I don't know if people know that, but in the line printers, that the laser printer could put 300 dots per inch each direction and do pictures and everything. It was so much better than what came before. That opens up new capabilities.
Right.
So you then say, with this new capability that is 2 orders of magnitude, 100 times or more than what I had before, what does this open up and what is it good for? This is good for something I used to do or I needed to do but didn't do, and that then lets us move forward. Portability makes a big difference. It's a big difference to be able to find messages in a fraction of a second compared to have to dial up, to AOL or something and log in to read your emails and stuff like that. But that was so much better than waiting for the mail to come, the snail mail. And each of those things, the fax machine, it opened up so many things, right? Because you could send a document, anything drawn or typed or whatever, you could send it immediately to other people. Now, what was interesting is about putting up with things that aren't so good. We worked really hard in word processing to be letter perfect, they called it. The output, you wanted it to look as good as a good typewriter, okay? Really, really good. Then we had the laser printer that could produce fonts of all sorts, perfectly sharp, indistinguishable from the old stuff. Then what do? We said, oh, we'll stick it in the fax machine that turns it down to 150 dots per inch, and whatever, and it's only black and white and no gray, and we'll send it that way. We'll take our letter perfect thing that we worked so hard and turn it into this barely readable thing on paper that was kind of wet and faded, whatever, but we could get it immediately,
Right.
and and we put up with that when we first had cell phones. Can you hear me now? Can you hear me now? It was, but
And they were enormous. They were huge.
they were huge, but at least you could carry it with you.
Right.
And so that's, you look at when you have a new capability, it opens up some things and you're willing to put up with it not being as good. A lot of this is described by Clay Christensen, may he rest in peace, and The Innovator's Dilemma.
Yes.
So about that whole thing about when you have something, a disruptive technology.
Yeah.
So we can look at that for any new technology we have today, and how is it better or not from what we had before, and what is it good for? What is it not good for? And what doesn't it matter?
Right. Right. This sort of trade-off when there's something like some new capability, but then there's this trade-off between quality and then portability. I think about music also, right? It's like the quality of music, by changing it and having it be into an MP3, you're losing a lot of quality.
For those that can hear that, not all of us can hear that. The thing is that the
true.
portability,
But
and the fact that you could carry in your pocket hundreds of songs, to listen anywhere. But the quality was pretty, compared to a transistor radio, listening on the radio, waiting to hear whatever happened to be on this tinny little speaker. When you had those really good earphones that the Walkman, when Sony did the Walkman, they did these really good earphones with these special magnets and whatever. So it actually sounded better than it probably would be if you used your expensive stereo in a noisy room.
Right.
So, and it doesn't matter because you're portable. You can do it when walking or running or when you're commuting. So yeah, this trade-off of, and then eventually they get better, where the sound quality you have with the latest little earphones, wherever, running off of, directly off your watch or your phone or whatever, are like concert quality compared to our old speakers that we had, in our dorm rooms or something like that years before for an expensive stereo.
Right.
So it does catch up. That's the innovator. That's exactly Clay Christensen's about how eventually the toy fixes the differences between it and eventually becomes better because of the volume and stuff like that.
So going into VisiCalc and creating something like that, what were, I guess, a couple of questions. Like, so when you're creating this general purpose tool, first, it's hard to think of all of the possibilities that you could, that you could hit, right? But I guess, could you talk about,
I had no clue. I mean, I knew about a lot because I was at business school learning about all different aspects of business. So I was exposed to many uses.
Right.
But it was a fraction of the uses that it actually became used for, even in the first year.
Right. Right. Yeah. Your story about, so you have a great TED Talk that I encourage all listeners to listen to, about the history of VisiCalc. But you mentioned there that you used the spreadsheet basically to help you with your case studies and to do projections and to do those sort of things, which personally is kind of cool for me, because one of my first case studies was your case.
Yeah, I mean, there's so much echoing of the past.
Yeah, so it's a pleasure to be.
And it was highly interactive. VisiCalc was highly interactive. I worked on the word processor with somebody by the name of Jack Gilmore, may he rest in peace, who was on the word processor. He developed what is arguably one of the first video games. Well, it is one of the first, but it arguably could be the first video games in 1951.
Oh, wow.
And on the Whirlwind computer. So, this moving along and from person to person to person, it's kind of cool.
Yeah, it's really cool. So while you were developing it, what were the challenges that you were facing? Were there I guess the technical challenges?
Yeah, so many challenges
trying to fit it. I know you mentioned that there was a particular upgrade in the Apple II that made it possible, I think, or there was some additional memory or something that allowed it?
Well, I mean, there was stuff. The thing is that, well, the Apple II was good enough, but the challenges were the Apple II had a very small screen in terms of characters. 25 rows of 40 characters wide on the screen for character based. And it had 2 arrow keys. That's it. It had paddles you could play game with, but I was going to use that like a mouse, but I gave up on that very early on. No, the type you turn.
Oh, okay, the turning one. Yeah,
so I should go get it. I have one, an old Apple II with it. It was for playing Pong.
Right.
You know, that was that type of stuff, or Space Invaders, which is what everybody wanted to play, which was a game on the Apple II. So the challenge was you're working with data that probably, you're going to want a lot of it. So luckily from my word processing background, I was used to scrolling and dealing with scrolling, but how do you deal with scrolling on such a small screen? So we had to do things like what we now call locked panes. We call them titles, where you would have, the name, some maybe row names or something. And as you scroll, they would stay on the screen.
Right.
And I'll let you have 2 windows so you could look at 2 places at once. You could do this and see the results of a sum somewhere else. And if you did 2 scrollings, they would be synchronized. So we decided to put that software in. Help, we wanted to have a help system, but there was no space to put that much information. The only help we had is you typed a slash and you got it showed you what characters you could type for the commands to put in. And /IR is insert row, which I think still, if you type /IR into some versions of Excel, it still inserts a row. Those letters that we showed on the screen were the same letters that we were comparing what you typed to see if, what to do next. To save memory. So memory, how do you store the numbers? First of all, we had to make it that if you saved it and bring it back again, it would still fit. So if you used up every byte of memory available on your computer, there was no, putting it out to disk or any of that paging stuff that we knew from our other days. So you had to build it so that it would be repeatable. Okay. And therefore you needed certain things to be very quickly garbage collected using fixed size, whatever. So what was the largest number that we would store? Because we needed to know that. And Bob and I talked about it, Bob Frankson, who wrote most of the code. And we'd said, okay, let's imagine that people would use this to calculate the budget of the United States of America in dollars. That's enough significant digits before we go to scientific notation, where it's powers of 10.
Right.
And sure enough, it ended up being used for that a few years later. But we had to make decisions like that. How many columns, how many rows, max? And when do we allocate memory to be fast versus how do we do it so that you could actually have a spreadsheet that could be this wide or could be this high, but it couldn't be both at the same time because there wasn't enough memory for it. We only had, I don't know, like 30K, 1,000 bytes of memory for your whole spreadsheet. We started on a system that was 32K bytes for the whole system. That was the program. The operating system, the screen buffer of what was going to be on the screen, and your data. Right. We could fit a few K of data for that. Most people had 48K, which was the biggest version. Then, though, we could use, if you bought a special card to run some other program that sold this card, you got another 16K of memory, and we could use that card to give you more memory, and people would spend hundreds of dollars on this card and throw away the software that came with it in order to get the extra memory for bigger spreadsheets. So we were very constrained. We had a program, Bob had a program really, really well to be able to scroll and, display. We didn't turn it all into the screen. You had to turn it into the screen dynamically as you scrolled. Right. That's a lot of programming. Well, it has to be fast enough for the repeat key. What we didn't know is that the repeat key was done with hardware that isn't based on time, but was based on an RC circuit, which means it varied from computer to computer. Our computer, you could scroll and stop, and it would stop. But some, if you stopped, it still had a few extra keys and kept going. But it had to be that fast. That was a real challenge to make it fit in memory, do all the things that we wanted it to do, And how do we decide what not to do? We wanted a great help system. We wanted more functions. We wanted, I mean, they're just, it's deciding what not to do is a very tough thing. And we had to make it easy to understand, to learn. And people learned by using a reference card and a manual. They either read the manual or they looked at the reference card or both that tell them if you push this key, it does that. And we had to make that as simple as possible, and we succeeded.
Yeah.
And useful.
Yeah, for sure. I mean, it's still the most used, one of the most used software. So VisiCalc was the precursor to Lotus 1-2-3,
Right.
precursor to Excel.
And then Google Docs and dozens and dozens and dozens of other spreadsheets that have been built.
Linux has their own open source version as well. What's funny is, designing software, often the competitor is the status quo. Mm-hmm. So you created something that's like the status quo, like any
no, the status quo was paper and pencil and a calculator.
I'm saying that it became, now that has
it was the status quo. Right. But it was pretty easy to beat us out if you were on a more powerful computer because you had more columns, you had graphing ability on the screen, you had lots more memory. And if you happen to know what people wanted, things we left out, like commas in numbers, the 1,000 separators, the columns being different widths, and some other things. And there were certain things we left out because they were hard to program, or we weren't willing to make certain compromises that other products like 1-2-3 did do and did very well because they had those. Right. And then when there was new hardware, so Excel could take advantage of fonts. Just think what Multiplan from Microsoft put in, and then Excel used, which was the ability to have a single line between each cell, to have a grid visible. That's a huge advance for many applications. Right. And they were able to do that because the hardware initially of the Macintosh, the early Macintosh, that they did, let you do that. So there are all these advances that you could put in new products. With Excel, you could run it under Windows, and it came bundled with your word processor with Office. And so whenever you bought your computer, it came with it. So that was a reason that people would go with that. So 1-2-3 was just much better for the IBM PC. It was tuned so much for it. The 1-2-3 was so tuned to the IBM PC, which had just come out, was now available from a major manufacturer. People now knew PCs were useful, so they were finally all buying them. This is Jeff Moore's, inside the tornado, and about the early adopters now going to the early majority, where there's a huge uptick. And IBM PC was the computer of the time, and the spreadsheet of the time was 1-2-3. And it came even with a piece of plastic, molded plastic, that went over the keyboard's function keys to label them. So you knew where help was, and you knew where this was, and all that, because you had physical labels on this piece of plastic tied to the hardware so much. So why not buy that? And so what did 1-2-3 cost, like $400 or $500? The computer with the printer and all that cost you several thousand, like $3,000, $4,000, $5,000 perhaps for your computer, with a printer and all the things that the screens and the stuff that you wanted. So the software, who cared? But you bought it for the software, which is what it means to be a killer app, that it's worth buying the hardware for that software.
Yeah, there you go. But thanks for tying that back in. Yeah, so the idea of having that killer app.
Even better is when you already have the hardware.
Right.
So like when Netscape came in with a nice browser, the idea of that type of a browser, there had been browsers before, but they weren't integrated with screen, with pictures and stuff the way that it was. There were just a few, and it was available for free. All you needed was a personal computer running Windows, and you needed to have that computer on a desk, and you wanted it connected to the local area network to be able, or somehow connected to what could be the internet or whatever. You needed that hardware all in place. And companies had that because of Lotus Notes, a product that Lotus did that was really good for email and workflow and all sorts of stuff. And it was one of the premier applications for Windows, help Windows being developed. And so the hardware was already there. You didn't need a killer app. All you needed was the good app. You didn't have to buy the hardware if it was already there. And then when Napster came around, you don't need to buy anything, right? When you needed a music player is when the MP3 stuff, and Napster and whatever came in. That was, you sort of needed that if you wanted portable music. But when Facebook came in, students already had computers. They already were connected to whatever. So they didn't have to be a killer app that way. They just needed to be a useful app.
Right. Almost like use the system that's in place to then kind of to move things
Once you
forward.
have a fertile environment, if you want a fertile environment, meaning it's a thing where it's a good place to do different types of applications and stuff that lends itself to innovating in different areas. So the PC was a fertile platform of sorts. And once you have that, you can do things for that. And we're seeing that today with AI, where people are using AI systems that other build as the fertile platform on which to build something else. Now that I have something that can take inputs and then do outputs in English. In terms of when something it's hard for adoption versus easy for adoption.
Right.
Now we have adoption in. It was just a thing I saw that David Smith wrote. David Smith wrote a product called Widgetsmith, which is on the Apple iPhone that lets you put widgets, customize them. And he writes about it, how he was building it originally for the watch, and then he was into customization, and Apple made it possible to do that. And then he came out with it, and it started selling like normal. Then somebody put up something on TikTok where they said, boy, you can customize exactly what I want, customize my screen to be exactly what I want. Within hours, he became the #1 app for a week or for 2 weeks on the Apple iPhone.
Right.
He sold millions and millions, I think, 100 million copies or something? And he didn't sell them all. But they're free. It was for free, but you can buy the upgrades.
Yeah.
I mean, within days or within hours, today is quite different.
Right. How fast you
can go up and how fast you can go down.
Yeah, that's for sure. I wonder, are there any new criteria that you add in to making a killer app today?
I haven't thought about it much, but I think the whole thing of whenever there's a new capability, look at what is it good for and better than anything before by not a little bit, but by a lot, 100 times better type of thing.
Right.
Now that you have that, what does that enable? So let's take machine learning.
Yeah.
Okay. The old machine learning, it was used for visual stuff to recognize things, and really kind of cool on the production line. You could see, is this a good one or a bad one? And you could then automatically, do some quality control and stuff. Well, what happens if you can put it on a small enough chip to be able to detect people by eyes, being able to say, that's a face. All you have to do is, well, that's a really tough thing to find faces. Okay. But they figured out machine learning and stuff. They figured out how to do that, and they put it into cameras. And we take this for granted. The fact that a camera can figure out it's a face and then do the autofocus there, not just the dot in the middle, wherever you point it. It used to be wherever you pointed it. That was the cool thing.
Right. Where
you pointed it was where it focused. This, it's able to say, oh, I see a face. I see two faces. Let's try to figure that out. What was it good for? It was good for that.
Yeah.
It was good for lots of other things. But so what is it good for? And that we could do that we couldn't do before, that's worth it, that pays for itself almost immediately. I say, within 2 weeks type of thing. When you got desktop publishing, a laser printer, something like PageMaker or later Word and stuff like that, being able to get your output and, do a newsletter or whatever. The old days, you had to type it up, send it out to a typesetter, to a person who would typeset it and then print it to the printer and come back. It paid for itself the first time you used it. There was a 2-week payback for a lot of these things. VisiCalc paid for the Apple II. There were certain programs you could use to do financial forecasting, not as easy to use and whatever. But for your particular application, you could use a time sharing system, $6,000 a month. Well, for $6,000, that's much more than to get the top end. You'd get an Apple II, a nice monitor, Sony's Trinitron probably or something, that I could use to watch TV, and a printer, the best printer that I could get at the time, a daisy wheel printer or something. So it pays for itself the first time I use it in a couple of weeks. No brainer. I mean, it's obvious. None of this 1 year payback, 2 year payback. So cell phones, the first time you're stuck somewhere and can't, with a flat tire that you can't change in the middle of nowhere, and you find out you could have had a cell phone. When your mother does that, you buy her a cell phone right away. I did that. She had a flat tire and, whatever. I said, Mom, you're getting a cell phone.
Right.
This is many, many years ago.
Yeah.
Or late enough for cell phones. So that's, when is it obvious that it pays for itself the first time you really need it or something? So that sort of gets into today's stuff. And separately is user interface.
Yep.
Why was my spreadsheet implementation versus other calculating things that came out, why was mine so successful? Was it just the marketing? Was it just the cool name? Was it our implementation? Was it, there were other, was it because it was on the Apple II? Was it, why, what was the things that made it, but a lot of it is user interface and stuff. And what were they good for? And is it fun? In the early days, when I first did computerized typesetting, in our office, we had a typesetter, thing used chemicals and stuff, whatever, that you could use as an output, like a printer. And out would come this paper, little shiny paper, that you could do fonts, a Times Roman and then italic and all that stuff, and different point sizes. And the first things we did were look like ransom notes. These are our status reports, where we could have just made it look like a typewriter, but no, we wanted to do all that. And sure enough, when the first word processors came out that did fonts with laser printers, what did everybody do? They went overboard. They used it for everything, and they made fonts like, and it was the most garish thing. And now we've sort of settled down.
Right.
And learned that. The same thing, it's the hammer. Once you have a hammer, everything looks like a nail. I love this new thing. Let's use it for this. Let's use it. I don't know what it's really good for, but I'll use it for everything.
Right.
With today's stuff, what's it good for? I can ask it a question and it gives me an answer. That's good. Well, it turns out it's not very good for certain answers.
Right.
And it's really good for certain other answers, and certain type of questions. And understanding that is important.
Yeah, 100%. And I think the challenge right now, you've seen all of the cycles,
Lots of cycles. It goes back, back to the Stone Age.
Right. The AI winters now.
Yeah. Look at my wheel.
Now we're in this, people argue where we are in terms of the, the hype cycle for AI right now. I think we're really high. I think some people are getting into that trough of disillusionment also a little bit, but I wonder for you, seeing it from your perspective, how do you separate kind of the hype of AI and the reality of it?
Well, a lot of people hyping it don't know what it is or what its limitations are.
Right.
What I used to say, let's see, when VisiCalc first came out, you could explain it or show it to people, okay? And if you showed it to a computer person, they look at it and say, what's so special here? I can write a program that does that, and I can do better and stuff like that. You show it to a regular person, a normal person, they say, computers can do anything. They can forecast the weather. They can tell you whatever they do. What's so special about that? But if you showed it to people who actually did that stuff, they would start shaking and say, here's my credit card. Please take it. Give me that. Give me that. Give me that. So the same thing's happening with a lot of stuff with like AI today is people look at it and they say, they don't really understand its limitations or what's what, but it looks like it's real smart, like a person. It can do things I can't. And I can ask a question, gives me an answer. And it sounds like a person doing that who is that confident must be right. And it's a computer, and it's trained on the whole web, and the web must have everything. There must be everything on the web. Well, we know that the web, not everything is on the web, and not everybody puts stuff on the web. So it's not trained on everything, and the people who are training it to check it don't always know the right answer,
Right.
etc. For me, what I need in my application, stuff I just saw it today or something, that a lot of training was on certain populations of medical stuff is in the literature, because they only did the studies on certain people they could get to.
Right.
But that's normal people. I mean, should understand well, maybe it's from my experience, it's different. That the training now is based on that, as that's what it is. There's an old joke about the policeman sees this drunk, and he's looking around on the ground, and he says, what's the matter? And he said, well, I lost my wallet at 23rd and Walnut. He said, well, we're at 19th and Walnut. Why are you looking here? He said, well, the light's better. And so what that is, that when we have the data, we use that. Whatever we can get, whatever is easy to measure is the thing that we measure, even though that may not be a good measure. But there are people who don't know that, who just assume that it must be all-knowing. Right. And it's better than me, so therefore it's good. So we learn. People who really use it learn to use the tool, like those that learn to use the spreadsheet, those that learn to use the word processor, those that learned how to drive a car, versus if you don't know how to drive a car, you're going to crash and you might kill yourself. Once you've learned how to drive a car and and stuff like that, then you can do also, and if you're really good, you might be a race car driver or something, you can do it. But you have to learn to do that. Dancing, learning how to dance. Some people are naturals, and you just look at one other. The same thing about these things. We have to learn how to use them and what they're good for. Unfortunately, they keep changing. So I become a prompt master. I'm really good at prompting for GPT-4 or 3. And I know all of what is good, and I know the way to do it and how to, and then of course it's changed. And suddenly my skills may not be as useful. Right. Things that I work really, maybe there are different ways to convince it for this. And that's just with one type of input, with one type of output. And it's changing so fast. Yeah. That's not a recipe to depend upon it. It's great for advancing. Are you going to let your life depend upon it? Reporters would ask lots of questions and learn lots of stuff about an area, something, and report about it. But if you knew that particular thing, you were at the event and you knew whatever, you knew what they wrote isn't exactly right. Right. Close enough, maybe close, but not necessarily exactly right. Especially if they weren't, had been in that area and whatever. There's the same type of stuff here, that we have something that, yes, it's pretty good. Is it perfect? Well, right now we're learning, like in coding, we're doing vibe coding, whatever, you have to check what it does. Yeah. Well, if you don't know how to check, if you don't know the type of failures that you might run, and we don't even know the type of mistakes that it might be prone to, that we have to look for what type of failures and what uses will be used for. And it keeps changing. So what it was good for, how do we know if it's still good at the thing that I want to do? It's going to take time to settle these things out. Is it still better than not using it? For some things, it is. And some people who know how to use it, like any tool, can get great advantage. Anybody who had a spreadsheet suddenly, in the early days of the Apple II, and nobody else knew they had it or what it was, thought they were these geniuses. They unbelievable. You did, what people would do is they would get a job, quote it for this many hours of money, go away, and then eventually when they needed to do it, spend the 15 minutes, use the spreadsheet to do the answer, and then come up with it. And wow, whatever, I got my money's worth. We're in that world for certain things. Right. So we'll see. And what was the best way? My idea of using the paddles was not a good idea on the Apple II. The mouse is good for certain things on the spreadsheet, but the arrow keys are good for others. Using the keyboard is better than, reading into, can you imagine voice input for a spreadsheet with numbers and words and all that? You can tell by anybody's texting who texts you with voice, you know whether, do you want to depend on your doctor using that type of stuff where the difference of voice recognition is life and death?
Right.
You may want different type of inputs with the right type of feedback. The feedback that we get from today's systems sometimes is, well, I can read it and I can tell where it's good or bad. For something that doesn't matter, because anything that gets me in the ballpark, I'm trying to get within the ballpark. I don't have to get to the seat. I need to be able to get to the ballpark. Right. So therefore, anything that gets me to the ballpark or nearby most of the time is a help. And you have to understand that. I mean, can you imagine if with today's systems at the error rate in terms of even small or big, you're using it to get to your seat in a ballpark or anything else? You think a lot of us would end up in the same seat by mistake and not in our others? With, I mean, we're talking about in a stadium, if you have 0.0001, mistakes, you're still going to have some people who are in the wrong seats. Right. So that's, you have to have the error correction and stuff. So I don't know how we're going to do that. I know that there's a real challenge with the interfaces to these different models that are using the technology that the LLMs use and the type of training and whatever. What is the best use of this technology for what type of things?
Right.
I'm really excited by new hardware that's coming out that will be able to do it. Apparently, some of the new phones and stuff, the particular chips in them are powerful enough and coming with the right software to be able to do certain things, even on, in your hand. And what's that going to open up? We're not going to just be talking. You're not going to want to talk to it. You're in a noisy environment. You're going to want to be able to do other ways of interfacing. We're learning. Remember with a lot of the visual stuff, it uses hand motion. Well, is that really the best way, or is it better to have a controller? We've now moved back to controllers. Remember the iPad,
right?
Everything,
the touch screen.
Yeah. With no pen. Well, now you sort of must have a pen to be able to use some of the stuff on the iPad for some of the applications. But we wouldn't have a pen when we can do touch. But it turns out that for the interface is better when you have, the sharp point, right, and the ability that people have, but you also need others for those that can't use their hands that way. There's accessibility.
Yeah.
There's where I'm using it, noisy environments, where I can't, how do I present things to you so you know what to check? Write me a 10,000 word, treatise on such and such. Well, how am I going to check if it's right? How do I know where to check? I mean,
the teacher will just use an LLM to tell you if it's right or not. No, I'm just.
Yeah, well, but then what's that trained on? To know what class is it? Then, and do you trust the person who trained that trained those systems? There are people you can read about. The people, they get some pretty good people to train these systems. To say no LLM, you got it wrong, whatever, right, and it fixes it and stuff. They still do weird stuff,
Still do weird stuff. I think that's one of the flaws, actually, that we're using human preferences. So it's trained to output things that humans prefer. And that's sometimes just off of like what you see and what you look like. And sometimes the formatting of an answer can cause you to like it more than some other answer. And how factual it really isn't always checked. There's so many challenges for it. We're so early, but it's interesting to see the way the pendulum swings. It's interesting to see what the new interfaces are gonna be like for it. Yeah. You raised so many good points.
Do we need new hardware? Well, first of all, we knew we needed new hardware to do the calculations. So therefore, they've been putting the neural engines and all that and all these all the hardware. So that's okay. So we've done that at least. But is there other hardware like we needed? Bitmap displays, meaning you could address every dot on the screen in order to be able to do, mouse and stuff like that. What other hardware, what interfaces, input-output devices do we need for the particular applications for which these things are useful for? Like if you don't have an autofocus motor, what good is being able to recognize where the person is and focusing, right?
It'll be interesting to see how those co-evolve with each other as these new capabilities, arise and emerge, and then there's going to be new hardware. I don't think we know yet what the right interface is exactly to take advantage of all of these things, but it
No,
is
which for
interesting.
each of these things, which interfaces for each of these things
Right.
is it going to be right for? We still know people still buy laptops, even though they have just as powerful phones. Why? Well, there must be something about that laptop that is better for them, that they're willing to spend $1,000 or a few hundred to $2,000 for that laptop, and versus their phone that they're also spending hundreds of dollars or $1,000 for. And so we have to sort of understand that whole thing.
Yeah. Yeah. You raise so many interesting points, so many things to think about.
It's hard to be an engineer because there's so many questions. And how do you decide now's the time for me to bet on this?
Right.
This combination. Is it too early or is it too late? Am I choosing the wrong combinations, the wrong application? And then there's the whole market fit. Do people care? And we don't know. That's why it was interesting to see David Smith, what he wrote about how he didn't know that there were, he cared about fonts, you choosing this font and this color and this type of little layout, whatever, this style for a clock or showing the weather, because he cared about that, but he didn't know that there were a lot of people that did care. He thought most people didn't because on other products they didn't care. But it turns out on your home screen, there are people who view the home screen like they view the case, right? And they view their clothes or something like that does matter to them, and that's how they express themselves. And he happened to hit the right combination that others did not. They also had some stuff, but they didn't allow you to do the chartreuse that you wanted or something like that made all the difference in the world to some people, and that was good for them. That's true of a lot of, if you don't know the space, you're not that type of surgeon. You may not know the needs for that type of surgery. If you're not that type of business person,
right.
You may not know the needs of that. The person using it works in this environment, physical environment. What must that hardware have? They only have one hand to do because the other hand is busy. So they have to do one-handed operation. That affects, there are just so many things that you don't always know it, and they have to go right for you to be successful.
Yeah, it's a good point. Taking into account when you're trying to design anything, right? Who your end user is, what environment they're going to be using your offering in, the context that they're in, the experience that they've had, and trying to create something that can kind of address, all of those things.
That's why I think that robots, humanoid-ish robots might be interesting in that so much of our society and the world around us is built around a person within a certain range with one or two hands, with this many fingers and whatever, and with this ability to move, etc., and this strength, and speed, that therefore maybe those input-output devices, which is the humanoid robot, may be appropriate to fit in situations that we couldn't automate without specialized machines. It's a real challenge, but what are the physical configurations that are appropriate for our physical world? The fact that a cell phone fits in your pocket matters. When the first really good scientific calculator came out, the Hewlett-Packard calculator, HP 35, the story is that Hewlett-Packard came to his engineers and said, I want something that fits in my pocket, my shirt pocket. They took out their measurement and they measured his pocket, and sure enough, it could fit. It was, a certain thing that he could fit in his pocket because he needed to be able to carry it around. Before that we had slide rules and we had special leather straps that fit them on our belts, and that wasn't for regular people. This you wanted to, and that size calculator became dominant. Right. And same thing with the phone. It fits in the pocket. Ones that were too big weren't right at first, right? Once the like the Nokia small cell phones came out that you could fit in a purse and you could fit in your pocket. That fitting in a purse and fitting in a pocket make a difference. What's really nice about the new iPhone Air? It's really, really thin and fits in your purse a lot better, among other
Right.
things, which is now
Yeah.
so packed. You put your phone right.
Right. I mean, going back to what we were talking about earlier in terms of like how the pendulum swings back and forth. Yeah, like cell phones were smaller at one point in some ways, and they now have gotten bigger, and now they're going back to being a little bit smaller and thinner.
Yeah, but it's
And then
lost.
there's other
But now
trade-offs.
we're doing folding to
Well,
get the
now there's
combination.
now there's the back to the flip, and then there was a time when who would ever have a full touch screen? And then there's other trade-offs in terms of when you make something so small yet so interactive, right? There's trade-offs in terms of battery life, right? And things like that. And then you have to weigh, those trade-offs. So that goes
What's
into
the sweet spot? We don't know what the sweet spot's going to be. And luckily, lots of people are trying, and we're seeing what sticks.
Right. Which I guess is just the exciting thing about technology evolution. Yeah.
Look what happened with automobiles, and stuff, automatic transmission, and stuff like that, anti-lock brakes and whatever. And then some things caught on, and then they became standard. I don't know how to drive an older car that doesn't have the backup checking and a backup camera and whatever,
And then we become so used to it, then you start to become
That's
so
dangerous.
used to it. Yeah. Which is,
that's why I'm really scared in my car that doesn't have those, it has a backup camera, but one of my cars doesn't have the sensors.
Right. And now we're so used to hearing that sensor when you turn the blinker on that that if someone's in your thing,
you just
you always need to check. You always have to.
Especially as you get older, if your neck is having a problem with the back and all.
So coming towards the end, I have two questions that I like to ask. What advice would you give your younger self? Maybe when you were kind of just, say, starting your career.
Oh, the career advice as opposed to personal advice.
Well, you could do both. But
personal advice is, yes, she's the right one. Okay. So that's, okay.
That's very important, finding the right
That's very important.
partner. Very important.
Okay. Finding a partner is important. And so what would I want to do different? I mean, because I really like how things turned out.
Yeah,
things could have turned out different where I could have made lots and lots of money, which I did not because of various business questions and stuff like that. On the other hand, I like my life and it's better than I expected it to be. So I don't know what advice that would change what I would have done, except that, let's see. I mean, choosing the right horses to get on. I mean, that's which technology one to ride when, how to make that decision. But I still don't know. I mean, all the things I've told you, some of it comes from what I've said I was saying back then that I learned then. That's kind of tough. Family matters. Enjoy the good times because they may be the good times. There's movie As Good as It Gets. There's some things that are as good as it gets. Enjoy them when you have them. When you have the really good time, enjoy that. Don't feel bad that it could be or whatever. I've had some really special things happen in my life, and been at unusual situations and no longer have that. So the more that hopefully I enjoyed them at the time that I could enjoy them, that's good.
Right. There's like a great quote that you reminded me of it's like about the good old days, right? And sometimes you don't know, like I wish there's a way to know you're in the good old days before you've actually left them. It's from The Office. It's a good quote that I recently came across again.
Now, many, many years ago, early in the days of Apple, Steve Jobs came to speak at the Harvard Business School to an entrepreneurship club or something. And I went to go visit. I was a graduate at the time. I had graduated at the time. So I went back and I raised my hand and said, "Hey, Steve, where are you? What are you expecting for the future? Where are you trying to go?" And Steve said, "It's the journey." Yeah. He was not looking for where he was. It was the journey. And that, I'd asked the same thing of Gates at some point. And, Gates I'd asked him about some stuff and he talked about how he was going to give money away. He sure did. Yeah. This was his success. We'll look in the future. And if he's successful, he'll give back that way. So that was the thing about enjoy the journey. I always, when I did a company, what I did was when I was paying people and sending stuff, I said, I want to do it that when you look back, if we fail, I want you not to feel bad about that you wasted your time here. I wanted you to say, I wish I hadn't, I want to make sure that I paid you enough that it isn't costing you to become poor or something like that. That may not be the best business, but I was a feeling I had that you want to do it so that you won't regret that you were doing that stuff because of if it doesn't pan out from that viewpoint. So do things, that's the thing of doing what you love. And you can't always follow that. You don't always have that option, but if you can, that's pretty good.
Yeah. It reminds me, your earlier remark, life's a journey, not a destination. Like we might be seeking all of these things, but it's really about the journey that gets us to where we are. I'm afraid that this last question is too close to that last one, but I always ask it, so I have to. Yeah. So what has a career in tech taught you about life?
I mean, I love tech and I love that. And I'm happy that I did it. So I'm happy I chose that and that I'm still doing it. I'm still programming. I'm still writing, and I'm still programming a lot by hand, because it's like people who like to paint.
Right.
They're not Picasso, they're not Rembrandt, but they like to paint, even though they're not, they're people like to play basketball. They're not LeBron, but they still like to play. You don't have to be the best. So that's one of the things about your career. But you also should think about what you're good at and what you like. There's these retrospective I saw last night about Robert Redford and about what he went through figuring out what his calling was in life, where, he realized he was in arts and he thought he was going to be a painter. He'd gone to France and stuff, and he thought he was going to be a painter, but then he ended up, in school for drama and stuff like that. And a teacher who told him, you're good and stay in that, type of stuff. And then he ended up on stage, and then he ended up on film, and then he ended up behind the camera, as a director, and figuring out and then of course, Sundance, in terms of giving it back, in terms of his love of the outdoors and stuff like that. That's an interesting thing to think about. Look at people's paths, how they got where they got, especially ones that seem happy with the path that they took and why. And so that's a good reason to read biographies of various people that have done stuff, to talk to people who would not have written a biography, or there being a biography of them, to find out and about that. Somebody contacted me that I knew from high school and said, Dan, I hear that you took pictures back in the old days and you have pictures of the play I was in. And so that's, and you still have them. I said, yeah, I scanned them for one of the other people who was his kids didn't believe that he was ever in a play, was the lead. And so sure enough, so I had the pictures, and this turned out to be a major memory in her life. I was into photography, and I had great pictures of her. And I found out something I didn't know. She was a shy person, and she had a crush on a guy. And she got Maria, and he was Tony. And I have pictures. She got to live out a fantasy. You get to live out all sorts of fantasies in life sometimes that you don't expect. I mean, they're not married and they haven't, they're friends, but they're different parts of the world, whatever. But looking at that piece of her life, and that turned out to be a major, in hindsight, for the two of them, that play turned out to be in high school, turned out to be a major good point along the way. Right. That I'm sure in terms of other things in their lives, they've had some other high points. I mean, I'm a grandparent, and they're just such incredible high points you can get as a grandparent, and stuff like that. And being a parent, and the same thing. So enjoy those, and they will happen, and don't belittle them when you have them. So that's advice that I have, including in your career. I mean, even if you're going to get fired at some point, you got to speak in front of a huge crowd and they clapped because they liked what you said, and you liked that feeling.
Right.
Maybe, I don't know. Or you have a product, you built a product and people actually use it. And then I did a product where you draw on the screen, but you can draw big and it shrinks it down. You could mark up PDFs. Okay. So, on an iPad, even though you didn't have to write real small. So I hear from this mother who said, thank God, I really love your your product. My daughter has cerebral palsy, and now she can do her homework herself because she's able to draw big on the homework, and she doesn't have to tell me what to do. Thank you.
Right.
I mean, that was like, I still remember, it was years ago. I still remember that moment. So you never know. There's a line in the play Rent, about helping other people and stuff like, and this thing about the relationship with other people, is part of what it's all about.
Yeah.
So enjoy those. If you do, there may be other things you enjoy more. Enjoy them. Ice cream.
I think it's really good advice, and it reminds people basically, like, you never know what the consequences of your actions are, but if you're kind of doing it and you have the right intentions and you're doing things for the right reasons, you could make an unbelievable you can have an unbelievable impact on other people. I think that's really beautiful.
The speech that I give with it, that the TED Talk is a piece of, I've had people years later say that I was inspired by that, and I went and did this thing totally different and whatever. And this product that we all know about is there because thank you.
Yeah, it's amazing. That's incredible.
Yeah. Or thank you for the spreadsheet. I was helping this other person learn the spreadsheet because they needed it, and now they're my husband. Thank you very much.
Yeah, and you never know.
You never know.
You never know what could happen because of doing one particular thing could then lead to unbelievable impact and unbelievable consequences
for others or for you.
Yeah. I think that's a really good place to wrap up. Dan, this was such a pleasure. It was
here.
Amazing.
I appreciate. I love your questions, the areas where you're going after, and stuff like that. And knowing your background makes it even more so in terms of your technical background and stuff.
It was really, really a pleasure to have you on. Thank you for all of the incredible work that you've done. Yeah, your TED Talk is inspiring. It's inspired me. Your case study was one of those first ones. Reading that and connecting with you is a real honor and a real pleasure. I really appreciate you taking the time to chat and let me pick in your mind.
My pleasure too.
Thank you, Dan.
On this episode of Learning from Machine Learning, I had the pleasure of speaking with Dan Bricklin, co-creator of VisiCalc, the first electronic spreadsheet and the killer app that helped launch the PC revolution. We explored what 5 decades of platform shifts teach us about today's AI moment. Dan's framework is simple but powerful. Breakthrough innovations must be 100 times better, not incrementally better. The same questions he asked about spreadsheets and word processors apply to AI today. What is this genuinely better at? What does it enable? What trade-offs will people accept? Does it pay for itself immediately? Most importantly, Dan reminded us that we never fully know the impact of what we build. Whether it's a mother whose daughter with cerebral palsy can finally do her own homework, or a couple who met learning spreadsheets. The moments worth remembering aren't the product launches or exits. They're the unexpected times when your work changes someone's life in ways you never imagined. Thank you for listening. Be sure to subscribe and share with a friend or colleague. Until next time, keep on learning.